Welcome back to another exciting episode of Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my brilliant co-host, Victor. Before we dive in, I just want to remind our amazing listeners that if you're enjoying our show, please take a moment to rate us on your favorite podcast platform. It really helps us reach more developers like you.
Absolutely, Sheila. Your support means the world to us. Now let's get into today's topic. We're continuing our journey through Chapter 2, Fundamentals of P2P Networks, and we'll be exploring the fascinating world of P2P protocols.
That's right, Victor. And to kick things off, I've got a tricky quiz question for our listeners. Are you ready?
I'm always ready for a challenge, Sheila. Bring it on.
All right, here goes. In 2021, what percentage of global internet traffic was estimated to be generated by P2P file-sharing protocols?
Ooh, that's a great question, Sheila. It really makes you think about the scale and impact of P2P technologies. I'm curious to see what our listeners will guess. It's interesting to consider how P2P traffic has evolved over the years, especially with the rise of streaming services and cloud storage. But let's not give away any hints. We'll reveal the answer at the end of the episode.
Exactly, Victor. Now, before we dive deeper, could you give us a quick overview of what we mean by P2P protocols?
Certainly. P2P protocols are essentially the rules and procedures that govern how peers in a decentralized network communicate and share resources. They define how data is transferred, how peers discover each other, and how the network maintains its structure without a central authority.
That's a great explanation, Victor. So, if I understand correctly, these protocols are like the language that peers use to talk to each other in a P2P network.
That's an excellent analogy, Sheila. Just like how we have different languages in the world, we have different P2P protocols designed for various purposes. Shall we explore some of the most influential ones?
Absolutely. I've heard of BitTorrent before. Can you tell us more about that protocol?
Of course. BitTorrent is one of the most well-known P2P protocols, primarily used for file sharing. It was created by Bram Cohen in 2001 and revolutionized how large files could be distributed efficiently.
That's fascinating. How does BitTorrent work differently from earlier file-sharing systems?
Great question. BitTorrent introduced the concept of breaking files into small pieces and allowing users to download these pieces from multiple peers simultaneously. This approach, known as swarming, significantly improves download speeds and network efficiency.
I see. So it's like instead of getting a whole pizza from one place, you're getting slices from different pizzerias all at once.
That's a delicious analogy, Sheila. And it perfectly captures the essence of BitTorrent's efficiency. Now, let's talk about another influential protocol, Gnutella.
Gnutella sounds interesting. How does it differ from BitTorrent?
Gnutella, developed in 2000, is a decentralized protocol that doesn't rely on any central servers. Unlike BitTorrent, which uses tracker servers to help coordinate peers, Gnutella creates a fully distributed network where each peer acts as both client and server.
So, if I understand correctly, Gnutella is like a potluck where everyone brings and shares food, while BitTorrent is more like a coordinated buffet?
That's a creative way to put it, Sheila. Your analogies are on point today. Now let's discuss one more protocol, the eDonkey network.
eDonkey? That's an interesting name. What's special about this protocol?
The eDonkey protocol, also known as ED2K, was designed for large-scale file sharing. It introduced features like multi-source downloading and file hashing to ensure data integrity. While less common today, it played a significant role in the evolution of P2P protocols.
I'm starting to see a pattern here. It seems like each protocol brought something new to the table. Are there any common challenges these protocols face?
Absolutely, Sheila. One major challenge is dealing with leechers, users who download but don't upload. Another is maintaining network efficiency as the number of peers grows. Protocols have to balance between having enough connections for robustness and not overwhelming the network.
That makes sense. It's like trying to keep a party fun when some guests aren't contributing to the conversation. Now, I'm curious about a potential pitfall. How do these protocols handle security and privacy concerns?
That's a critical point, Sheila. P2P protocols often struggle with security and privacy. For instance, BitTorrent transfers are typically unencrypted, which can expose user activity. Some protocols have implemented encryption and anonymity features, but it's an ongoing challenge in the P2P world.
Wow, there's so much to consider. Before we wrap up, do you have any interesting facts about P2P protocols?
Here's a fun one. The concept of P2P protocols isn't new at all. In fact, Usenet, one of the earliest P2P systems, dates back to 1979. It's amazing how long decentralized communication has been around.
That is fascinating. Now, let's reveal the answer to our quiz question. In 2021, it was estimated that P2P traffic accounted for approximately 2.4% of global internet traffic. While this might seem low compared to earlier years, it still represents a significant amount of data transfer.
Indeed, Sheila, and it's important to note that while the percentage has decreased over the years, the absolute volume of P2P traffic has likely increased due to the overall growth of internet usage.
Thank you, Victor, for all these insights. To summarize today's episode, we explored 3 major P2P protocols: BitTorrent, Gnutella, and eDonkey. We learned about their unique features, how they evolved to solve different problems, and the challenges they face, particularly in terms of efficiency and security.
Excellent summary, Sheila. Remember, listeners, understanding these protocols is crucial for anyone looking to develop decentralized applications. They provide valuable lessons in distributed system design and peer coordination.
Absolutely, Victor. And to our wonderful listeners, if you found this episode helpful, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us continue creating this content. Don't forget to subscribe and rate our podcast. It really does make a difference. Until next time, keep coding and stay decentralized.